This video, we're going to talk about 2.1 Objective 3, where we construct expanded frequency distributions. Let's go ahead and get started here. After constructing an expanded frequency distribution, what should the sum of the relative frequencies be, and explain? The sum of all the relative frequencies should be 1. And that is because we'll have the individual frequencies over n. N is the same denominator for each of them. So if we have something like f1 over n plus f2 over n, these are all the individual relative frequencies all the way out until the nth relative frequency, like that. And we can put them all over the common denominator of n, and that's the sum of the f's, which is n. If we add up all the frequencies, we get n. So n over n is 1. All right, let's go ahead and take a look at this problem here. Use the frequency distribution shown below to construct an expanded frequency distribution. And high temperatures are given here in this regular frequency distribution here. And we're going to make an expanded frequency distribution where we find the midpoint. So let's find 16 plus 26, divide by 2, and we get 21. Then the class width is 27 minus 16 is 11. That makes this 32, 43, 54, 65, 76, and 87 for my midpoints. Relative frequency, we're going to divide f by n. Let's go ahead and find n. 17 plus 44 plus 68 plus 69 plus 77 plus 68 plus 22. And we probably would have guessed this. This is 365 because that's the days in the year, and we've recorded high temperatures for each day, even though they didn't tell us that specifically. So we're going to take each of these numbers here and divide them by 365. Let me let my calculator do that. It's much better at that than I am. So 17, 44, 68, 69, 77, 68, and 22. And I just want to take everything that is in L1, and I want to divide it by 365. And so I have, when I round this to 2 decimal places, 0.05. Then we have 0.12, 0.19, 0.19, 0.21, 0.19, and 0.06. And we're going to find that if we had left all of these relative frequencies as fractions and added them together, we would have gotten 1 perfectly. But because we rounded here, if I would add all these decimal parts perfectly, I would get 1. But you're going to see that we're going to be a little off here because of our rounding. But since this was a question earlier, I'm going to show you that it's very close. And the sum of these is 1.01, very close to 1, but not exactly because we rounded. Now our cumulative frequency, we're going to start off with 17. We're going to have 17 plus 44. It's going to give me 61. plus another 68 is going to be 129 plus 69 is going to give me 198 plus 77 is going to give me 275 plus 68 is 343 plus 22 is going to give me 365. And if I had been in doubt of what n was, this is one of the ways that I could have found n, is find my cumulative frequency, and there's n that I can use to find my relative frequency. And I may need to do that. I may need to just add and get my cumulative frequency. But this tells me that there's 365 things that are less than or equal to this range right here, 343 that are less than or equal to that one, 275 that are less than or equal to this one, and so on, so that there were only 17 that were less than or equal to this class, because there were only 17 in that class and nothing below it. I believe that's it. Yes, it is. So we'll come back next time and talk about 2.1 Objective 3. We'll see you for the next video.